What if the James Webb Space Telescope has not simply discovered another cosmic anomaly, but found evidence that the universe itself may be hiding the truth about where it came from? For years, scientists believed the cosmos followed one simple rule on the largest scales: no preferred direction, no cosmic spin, and no special pattern written into the very structure of space itself. Galaxies could rotate in either direction, but across the universe those rotations should balance out like coins tossed into the dark. But James Webb has now looked deep into the ancient universe, and something does not appear to be balanced. Hundreds of distant galaxies seem to prefer one direction of rotation, as if the cosmos itself may have been born spinning. If that pattern is real, then the consequences are almost impossible to ignore. A rotating universe could point toward one of the strangest possibilities in modern physics. Maybe the Big Bang was not the absolute beginning. Maybe our universe exists inside something much larger. And maybe James Webb has revealed something no one expected to see. Before Webb uncovered this unusual clue, it had already shown that even our nearby cosmic neighborhood is far more dangerous and complex than scientists once believed. Using its powerful infrared vision, Webb helped identify a large population of tiny asteroids in the main asteroid belt between Mars and Jupiter. Many of these objects are only tens of meters across, making them extremely difficult to detect. They are not the giant planet-killer asteroids that often make headlines, but they are still capable of exploding with devastating force if they enter Earth's atmosphere. That matters because objects of this size strike Earth much more frequently than larger asteroids. Some are small enough to remain hidden until almost the last possible moment. Webb's ability to detect them provides scientists with a valuable new tool for planetary defense, not by looking to the edge of the universe, but by quietly monitoring dangerous debris within our own solar system. Webb also turned its attention to TRAPPIST-1, the remarkable planetary system located about 40 light-years away, where 7 Earth-sized planets orbit a cool red dwarf star. The telescope found evidence suggesting that the inner planets may be far more complex than expected, with possible signs related to atmospheres, young surfaces, volcanic activity, or ongoing geological evolution. That has become a recurring theme of Webb's discoveries. Our solar system is more complicated than expected. Exoplanets are more complicated than expected. And now the universe itself may be more complicated than expected, because the real discovery is no longer about one asteroid, one planet, or one star system. It is about the shape and nature of the entire cosmos. Researchers studying hundreds of distant galaxies observed by James Webb noticed something deeply unsettling. Their rotations did not appear to be perfectly random. According to the standard cosmological model, galaxy spins should have no preferred direction. Some galaxies should rotate clockwise, while others rotate counterclockwise. Across a large enough sample, those numbers should roughly balance. That assumption is fundamental because modern cosmology depends on the idea that, on the largest scales, the universe looks essentially the same in every direction. Yet Webb's observations appeared to reveal an imbalance. A surprising number of early galaxies seemed to rotate in the same direction, creating an unexpected pattern where randomness was predicted. Even more intriguing, earlier studies involving much larger galaxy surveys had hinted at similar asymmetries. If those results hold up, Webb may not have uncovered an isolated curiosity but instead added new evidence to a much older mystery. Of course, scientists remain cautious. The apparent effect could result from observational bias, instrument limitations, data processing methods, or selection effects. The universe often surprises us, and many apparent anomalies disappear as better observations become available. But if the pattern proves to be real, then the implications become extraordinary. Galaxies should not somehow know which direction the universe prefers to spin, unless the universe itself was born with rotation. That possibility is where the mystery becomes truly fascinating. A rotating universe already sounds strange, but one proposed explanation is even more astonishing. Some physicists have suggested that our entire universe could exist inside the interior of a black hole. In the conventional picture, a black hole represents an endpoint. Matter falls inward, crosses the event horizon, and disappears into a region where gravity becomes so intense that even light cannot escape. However, some theoretical models propose a far more radical possibility. Perhaps black holes are not only cosmic graves but also cosmic birthplaces. In this view, matter collapsing into a black hole does not simply vanish into an impossible singularity. Instead, quantum effects might prevent infinite density, allowing the collapse to rebound into an entirely new expanding region of spacetime, a new universe born on the other side. To an outside observer, the black hole would appear frozen because time slows dramatically near the event horizon. But from the perspective of the interior, that same process could unfold as a Big Bang. If the matter entering the black hole possessed rotation, then the newly formed universe might inherit that same angular momentum. This is why Webb's observations of galaxy rotation have generated so much interest. If the alien universe truly exhibits a preferred direction of rotation, perhaps that direction is not random at all. Perhaps it represents a fossil imprint of motion that existed before our universe began, not stars, planets, or galaxies surviving from another cosmos, but motion itself, a hidden angular memory carried through the birth of everything. The greatest challenge in this idea lies with the singularity at the center of a black hole, the prediction that matter collapses into infinite density within a volume of zero size. Physicists have long been uncomfortable with that conclusion because infinities usually indicate that our mathematical models have reached their limits, not that nature itself contains something truly infinite.